And we are back live from room 216 at Grammars Christian High School to go through section 9.6, solving right triangles. This will be the last section that we look at from unit 9. So we're going to dive right in here. Previously what we looked at is this acronym of SOHCAHTOA, and that is going to be once again a key contributor to the lesson today. But what you've noticed, or hopefully what you notice, is all of the time that you've been using SOHCAHTOA, you have been solving for a side length. And we're going to continue to use SOHCAHTOA for side lengths, but then we're also going to see how we can use SOHCAHTOA to solve for missing angle measures as well. Okay, so if you notice, I'm going to jump down to letter A here. To find to use SOHCAHTOA to find missing angles, what we're going to use is what we're going to actually call the inverse. So what I want you to do is I want you to associate angles with inverse. Finding angles using the inverse. Angles, inverse, angle, inverse, angle, inverse. This is all just notation. This is right here, tangent inverse. This is cosine inverse. This is sine inverse. Okay, that little to the -1 power, you're not actually doing any number to the -1st power. This is simply notation for inverse tangent, inverse cosine, and inverse sine. They are on your calculators. They are built into your calculators to be able to do that. On a lot of the calculators, if you notice here, it is hiding behind the sine, the cosine, and the tangent. So mine is in blue. So to access sine inverse, I would have to hit second sine. Well, actually, I probably want to turn my calculator on first. Hit second sine, and then when I hit second sine, notice what comes up, and that is sine inverse. And once again, we will be using sine inverse, cosine inverse, and tangent inverse when we are finding angles. Okay, so when you're solving for an angle, you will use inverse. And I'll show you what I mean by that in just a second. Last thought before we dive into examples in letter B here, when it says solving a right triangle, basically what this means is you are going to find all of the unknowns. So if you don't know a side or you don't know an angle and the directions say solve a right triangle, you need to find it. You need to find everything that is missing. That is how you solve a right triangle. We're going to do an example of that very soon. Before we dive into that, we're going to just get back to this inverse question here. If you're solving all of this down and you end with the answer tangent of A is equal to 3.29, and if you're solving for the angle measure, the angle measure is not 3.29. What's 3.29 is the tangent of the angle. So what we would really like to do is get rid of tangent so that I just have whatever my angle is left over. So how we can get rid of tangent is by doing inverse tangent of both sides. So what that will do is that will cancel out the tangent here. We'll just be left with angle A, which is what we want. And then in our calculators, we have to do the inverse tangent of 3.29. So then I will do that. Second tangent. So the inverse tangent of 3.29. And I just put that into my calculator, and I get an angle measure of 73.1 degrees. Okay, so very easily just putting that into my calculator. Okay. Once again, to get rid of sine, how do you get rid of sine? You do sine inverse of each side. So then sine inverse will knock out the sine from this side. You'll just be left with angle B, which is what you want. But what you do to one side, you have to also do to the other side. So I will do the inverse sine of 0.55. And putting that into my calculator, I realized that angle B must have been a 33.4 degree angle. And lastly, to get rid of cosine, you will do inverse cosine of each side. So I will do inverse cosine of 0.87. And the answer to that question is that angle C must have been a 29.5 degree angle. So, like I mentioned at the beginning, if I'm solving for an angle, I will be using inverse. Angle, inverse, angle, inverse, angle, inverse. So since all of these I'm solving for an angle, I need to use the inverse. So not only will we use SOHCAHTOA for solving for sides, we will also use them for solving for angles, which we will see here in this example. The directions say here in number 2 to solve the right triangle given. So since it says solve the right triangle, once again, that means find all of the unknowns. Find all of the unknowns. What don't I know? I do not know the measure of angle C. I do not know the measure of angle, well, let's call this angle A up there, and I do not know the measure of this distance right here. So there are 3 things I need to find. I need to find 2 angles, and I need to find 1 side length. I'm going to start with the angles. I'm going to first start with C, to find angle C. How can I find angle C? Well, I'm going to put theta right there. And from here, I'm going to label opposite, adjacent, and hypotenuse, because I think that's going to be helpful to figure this out. Opposite of angle C is right here, so I'll label that with an O. This is my hypotenuse, because it's across from the 90, and this is my adjacent side. So I have to figure out what trig function am I going to use. Am I going to use sine, am I going to use cosine, or am I going to use tangent? And if you look at this right here, since I don't know my angle, but I do know my adjacent side and my hypotenuse, I'm going to use that adjacent side, I'm going to use that hypotenuse to solve for my missing angle. So if I'm going to use A and H, then I'm going to use cosine. So to solve for angle C, what you can do is you can say that you know that the cosine of theta, cosine of angle C, is equal to adjacent over hypotenuse, which is 24 over 25. So, well, what is 24 over 25? 24 divided by 25, if you do that on the calculator, this proof right there is 0.96. So now this question becomes exactly the same question as what we did on the other side. How do you get rid of cosine? The only way to get rid of cosine is with inverse cosine. And since I'm solving for an angle, I know I'm going to have to use the inverse. So I take the inverse cosine of each side, and the inverse cosine of 0.96 is 16 point, it says 10th place, so 16.3. Okay, so angle C is 16.3 degrees. Okay. So that will work, and that will work out well. Now, there's a variety of different options that you can use to solve for the remaining angle, angle A. Okay, you could set up a trig ratio, and if you're going to set up a trig ratio from angle A, the 24 would be your opposite side, and the 25 would be your hypotenuse, so O and H, so you could use sine. So you could use the sine of A equal to 24 over 25, and so you could set it up that way. You could set it up using this angle right here, or what I think might be the easiest at this point is recognizing that there's 180 degrees in a triangle, and you know the other 2 angles are 90 and 16.3. So what I'm going to do to solve for angle A, I think this is the quickest way, is just to do 180 minus 90 minus 16.3. And when you do that, you're going to get an answer of 73.7 degrees. I think that's the quickest way to go about doing it. Now, is that that may not always be the case, but if you're given 2 angles and you're solving for the third, I think that would be a pretty good method. Okay, so we solve for angle A, we solve for angle C. Now the last side is this one over here. You could solve using the Pythagorean theorem and do x squared plus 24 squared is equal to 25 squared, and that would work. But what I'm actually going to do is I'm going to use trig, just because I want to get triggy with it. So what I'm going to use is I'm solving for this side. I know that angle C is 16.3. So since I'm solving for this side, I'm going to use this side and my hypotenuse. So the opposite side and the hypotenuse, O and H. So since I'm using O and H, I will need to use sine. So the sine of angle C, which we've already figured out is 16.3, the sine of that angle is opposite side, which is what I'm looking for, over the hypotenuse, which is 25. So then in my calculator, I will just hit normal sine 16.3. Sine of 16.3 is 0.28 equal to x over 25. So then I'll take this number and multiply it by 25, because to get rid of divide by 25, you will multiply by 25, and when you do that, you should get an answer of roughly 7. And in fact, it will be exactly 7. Okay. So there really are a variety of different ways that you can go about solving, just whatever you feel most comfortable with. And notice I solved for every missing piece, the 2 missing angles and the 3rd missing side. Okay, and then number 3, we won't do it for the sake of time, but it would be very similar. You have to solve for x, solve for y, and you have to solve for big angle y as well. Okay? So we're going to do a couple more example problems, and then we will be done. For each of these example problems, I'd recommend drawing it first. So you're building a rake stage. The stage will be 25 feet long from front to back with a total rise of 1.5 feet. You want the rake to be 5 or less for safety. Is this possible? So right now you don't know the angle. You're hoping that it's under 5, but you don't know the angle. So I'm going to build my triangle here. It's 25 feet from back to front with a total rise of 1.5 feet. And what you don't know is you don't know this angle. You're hoping that this angle is less than 5 degrees for safety. So let's figure it out. But before we figure that out, we have to figure out what trig ratio we're going to use. So from here, this is my opposite side, this is my hypotenuse, and this is my adjacent side. So since I know this and I know this, I know my O and I know my A. So since I know O and I know A, OA, TOA, I'm going to use tangent. So the tangent of my missing angle is equal to opposite over adjacent, 1.5 over 25. You can do this all in one step, but I'm just going to do it in 2 separate steps so that you can see what I'm doing. 1.5 divided by 25 is 0.06. And then now to get rid of tangent, you will make sure that you do the inverse tangent of each side, which should make sense because inverse is always solving for an angle. We are solving for an angle. And when you do the inverse tangent of 0.06, if you do that on your calculator, you could do this as well to make sure that you get the same thing. You should get a 3.4 degree angle. So if you get a 3.4 degree angle, that is less than 5. So for safety purposes, yes, it's possible because the angle is 3.4, which when I was in school, 3.4 was less than 5, and I believe it still is. So we'll do 2 more, and then we will be all set. Okay, number 5, once again, you can read through it, and then if you just ultimately realize, hey, the triangle is going to look like this. A rise of 403 and a run of 685. What angle is made with the track and the run? So you're looking for this angle. This is your angle theta again. And once again, we're going to use tangent because we know the opposite side and we know the adjacent side. So the opposite side is 403 and the adjacent side is 685. So then on the calculator, I will do 403 divided by 685. And 403 divided by 685 is 0.59. And then now since we're solving for an angle, we will use inverse. My angle is not 0.59. My tangent of the angle is 0.59. So to get rid of tangent, you will do inverse tangent of both sides. And when you do the inverse tangent of each side, you come up with an answer of 30 0.5 degrees. So it's a 30.5 degree angle. And this is the work that we would expect you to show for that. And last question, last example here, then we are done. A 30-foot ladder is placed 6 feet from a wall. So here's the wall. It's placed 6 feet from the wall, so that's 6 foot right there. The ladder itself is 30 feet, obviously not drawn to scale. What is the angle the ladder makes with the ground? So you're looking for this angle right here. So this time we're not going to use tangent because what we have is here's the opposite side, here's the hypotenuse, and here's the adjacent side. So I'm going to use A and I'm going to use H. I'm going to use the ones that I know. I know 6 and I know 30. So I'm going to use the A and the H. So if I'm using A and H, so toa. So I'm going to use cosine. So the cosine of my angle is equal to adjacent over hypotenuse, 6 over 30. 6 divided by 30 is 0.2. Oh. And now to undo cosine, you'll do the inverse cosine of both sides. And the inverse cosine of 0.2, and once again, I would recommend checking this for yourself as well. It's 78.5 degrees. So the angle that it makes with the ground is 78.5 degrees. So anytime you're solving for an angle with trig, keep in mind you are going to be using the inverse, angle inverse, angle inverse, angle inverse. And I think the other tricky part is just making sure whether you're going to use sine, cosine, or tangent. So be steady with SOHCAHTOA and stick to that, and you should be good to go. So that ends Unit 9. Good work. We will see you soon.